Hello everyone. So today we're gonna be learning some math. And what part of math? We're gonna be learning numbers. And a lot of you are like, numbers is such a stupid thing to be learning about, right? Why do we even need to learn about numbers? Right? Numbers is just 1, 2, 3, there's not much to learn about numbers. But you are wrong. Because there's actually a lot of interesting things about numbers. Right? There's some numbers that we don't there's some things that we don't know. For example, there are a lot of different categories of numbers. There are whole numbers, there are natural numbers, there are rational numbers, and there are real numbers. And we'll deep dive into every single one of them so you will understand them. Okay, so firstly, let's learn about the most basicest of basics, whole numbers. Now, whole numbers is very simple. Whole numbers basically are all positive numbers plus 0. Now, take note, a big misconception is 0 is positive. This wrong. No, 0 is not positive. Okay. And then you'll be like, oh, that means 0 is negative. Wrong. That 0 is neither positive nor negative. So it doesn't have to be, oh, you're not positive, that means you're negative. Or you're not negative, that means you're positive. It can be neither positive nor negative. So 0 is the only number in the scale that's like that. Okay, so basically, whole numbers is basically all positive numbers. Now, but the thing is, positive numbers starts from 1. You go 1, 2, 3. Oh, okay, I think it's glitching. Okay, 1, 2, 3, blah, blah, blah. But here's the thing. 0 isn't included. But here's the thing. In whole numbers, 0 is included. So, it's basically, what is whole numbers? Essentially, it is just 0 plus the positive numbers. Okay? Alright, now let's deep dive into the next type. Okay. Whole numbers is just the most basic version. Now let's deep dive into natural numbers. What are natural numbers? So, natural numbers, simply put, are positive numbers. That is literally what natural numbers means. Which basically means you count up from 1. 1, 2, 3. So, therefore, negative 6, negative 3. What's this? They are not natural. How about 0? Now, as I said before, 0 is neither positive nor negative. Just now when I was explaining whole numbers, I said positive plus the extra one called 0. But in this case, natural numbers, it's only positive. Only. So 0 is not one of them. It's literally only this set. Okay? So that's literally it for natural numbers. Integers. Now what are integers? Integers is when you bring negative inside. So, let us draw a little number line. It's a super simple number line. 0, 1, 2. Negative 1, negative 2. Okay, now, this is the not positive, not negative. This side, they're all positive. This side, they're all negative. So, we know that this is natural. This is whole. But here's the thing. What if we bring it all these into the equation? If you bring in everything, including negative numbers, you call it integers. So integers are basically what I say for integers is positive numbers, 0, and negative numbers all together. That is integers. Okay, that is literally integers. So integers are basically all this stuff. Okay, so now let us go through another one. Okay, rational numbers. Maybe you haven't heard this one before. Maybe you have, but you don't exactly know what it is. And this is a bit confusing, so I'll need to slow down. Okay, now. Okay, make a bit too big. Let's just get a bit. For rational numbers. Now, a very easy way to say it is basically can be expressed as A over B. Basically, don't say it this way. That's what mathematically they say, but to me, it's basically just can be expressed as a fraction because A over B is a fraction. So, any number that can be expressed as a fraction. So, of course, all integers are rational. Because integers, let's say 6. 6 is literally a fraction. Technically, over 1. 7, a fraction. Right? Let's say, let me take negative numbers. Negative 6. Negative 6 over 1. So, you see, it's all over 1. But now, what are some examples of rational numbers that aren't integers? For example, we can have half. Half. It's a fraction, and literally the rule is can be expressed as a fraction. So it works perfectly well. Which basically means that any fraction, it can be 3/4, it can be 5/6, it can be 67 over 83. It's all rational. Now, let's move on. How about decimals? Decimal, let's say, what? 7.4. It can be expressed as a fraction. What is it? 74 over 10. That's a fraction, right? I know it can be simplified, but yeah. Let's say 3.48. It still also can be expressed as a fraction, right? 348 over 100. So all these can be expressed as a fraction. Now, let's do another one. What if it's a continued fraction? Now, I will dive into continued fractions in another video, but continued fraction looks something like this. Sorry. Okay. 1 over 1 plus 1 over 1 plus 1 over 1 plus 1 third. This is a continued fraction. Now, let's see this way. The rule is can be expressed as a fraction. This is technically a fraction. So yes, correct. This is still rational. Okay. Now let's try another one. How about this? Now, in case you're wondering what this dot means recurring. And what recurring means is that it will keep repeating, which basically means 0.3333333 dot all the way. You may say, oh, that's definitely not rational. But guess what? It is. Why? Because can this be expressed as a fraction? Maybe some of you think it cannot, but it can. In fact, all recurring decimals can be expressed as fraction. Alright, and I will have another lesson on how to do that. So, I'm going to have 0.784 with 84 recurring. And that can be a fraction. Okay? So, that is literally recurring decimals also fraction. Also rational. Now, I think it's about time where I give you some examples of things that are not rational. So, we are just going to add this. Irrational. Now, what are numbers that are rational? At this point, you may think every single thing is rational at this point. But let me give you examples that are irrational. Okay, here it is. Now, those of you who don't know, this is pi, which basically is the thing that will help us calculate the area of a circle. Pi r squared calculates the area of a circle. Now, a lot of you are like, Hey, wait, what? I can actually find a fault in that. Why? Because pi equals to 22/7. And thus, this is a fraction, right? So pi is rational. But what if I want to tell you that pi does not equal to 22/7? So, later I'll explain a bit more on why that is. So actually, 22/7 is rational. Indeed, it is rational. But pi is irrational. Which at the start doesn't make sense. But I thought these two are equal to each other. But they're not. Now, 22/7 is just a rough estimate of pi, but it cannot define the exact value of pi because pi is endless. It's 3.14 blah blah blah, and it can never end. It will practically never end. So 22/7 is just a nice way of trying to give it a fraction. But because it can never end, there is no exact fraction that can represent pi, which is why pi is irrational because it cannot be expressed anyway. Now, it's not just pi. There are also other values, sort of like pi. E. E is Euler's rule. And that is also irrational. Okay? Because it cannot be expressed in a fraction. All these that I'm going to give you cannot be expressed in any fraction. Or how about the square root of 2? Or the square root of 5? We know the square root of 4 is equal to 2. But this cannot be square rooted, this cannot be square rooted. And if you click your calculator and you try to convert it into a fraction, you can't because it's irrational. So all these are irrational. Okay. Now let's move on to the final boss, which is real numbers. Now, I'm just gonna tell you one thing and we are done with this lesson. Okay, actually I'm not done with the lesson yet. One thing and I'll explain you straight away what's real. Numbers that exist. It's literally this definition. Numbers that exist. So, pi, I know it is irrational. It cannot be defined as a fraction, but it is still indeed a number that exists. E is still a number that exists. The square root of 2, it cannot be defined as an exact fraction, but it is still existing. Are there numbers that are not real? So, the last version of numbers, and later we'll do a quick revision. The last version of numbers are numbers that aren't real, which are called imaginary numbers. Now, imaginary numbers are numbers that you think of yourself. It's like fake numbers. They don't exist. Okay? They do not exist. So, then a lot of you are asking me, wait, what? But what? Give me an example of numbers that don't exist, right? So, let me give you an example. This. The most classic example of imaginary numbers. Basically, what this is the square root of -1. Now, if you put it in a calculator, the answer will be math error. Why? Because this has no answer. So here's the thing. When just now, okay, I'll explain why this has no answer later on. But firstly, just now, when we went through square root of 2, right? I know that is irrational. It cannot be expressed as a fraction, but there's still some form of answer when you click it in the calculator. This has no answer. So this is just a thought of value. There is no value to this. Basically, an imaginary number is a number that has an actual value that exists in the number line. But this, what is the answer to this? I cannot answer you. I do not know. I do not know. What is this? I do not know. So basically, the square root of -1 has no answer. And I'll explain why later. Actually, I'll explain why right now. Now, this goes to any negative number that is being square rooted or rooted to an even exponent. Now, if I have a negative number, let's say -3, and I go ahead and try to do this. Okay, wait. Okay, let's not do -3 because -3 itself cannot be square rooted. This. There's no answer. Why? Okay, now I give you an example. Let me give you an example. We all know that 2 times 2 is 4. In the negative side is still 4. Can you find two values that equal to negative 4? When you multiply together, you get negative 4. No, you don't. Because of the fact that a negative times a negative, you get a positive. And a positive times a positive, you still get a positive. That is why it makes a contradictory sense that it is impossible to physically get a negative. Unless you have something like this. Unless you have this. Okay, if I have negative x times negative x, the answer that I get, nothing. I mean, I'll get a positive answer. Sorry. I'll get a positive answer. But if I do it 3 times, 1, 2, 3, I will get negative. That's another new value, negative y. Why is this? Because first time is negative. When I multiply by negative number, the second time is now positive. But then I go and multiply by another negative number. Oh, sorry, now you're negative again. That's literally how it works. That's why you get negative again. So if you notice, I took this and I multiplied it 3 times. 3 times. Negative, positive, negative. If I go and do it 5 times, it will be negative, positive, negative, positive, negative. If I do it 7 times, negative, positive, negative, positive, negative, positive, negative. Still in the end, you will never have negative. Because these are all odd. But if I do it 6 times, negative, first time, positive, second time, negative, third time, positive, fourth time, negative, fifth time, positive, sixth time. Aha! So, notice how, if I have a negative number, and I go and power it to an exponent that is negative, that is odd, I will get a negative number. But if I get a negative number and I go and power it to an exponent that is even, I will get a positive number. Thus, the most basic form, just squaring it, which is even, you will get a positive number. Which is why it's impossible to square root it from a negative number. Because there is nothing, there's no answer to that. There is literally no answer. Okay, so that is literally why I say so. Okay? So that's the imaginary number. That's all. And if you have something like this, let's say so 2 times 2 times 2 times 2 is 16. Negative 2 times negative 2 times negative 2 times negative 2 also 16. Nothing will ever equals to this negative 16, sorry, negative 16 now. Nothing will ever equals to negative 16 if you're gonna cube it 4 times. I'm sorry, not cube, square it. I mean not square, but like power it out. Okay? To such an index. Okay, so now before we end this video, okay, we're gonna do a little quick revision. And I'll also teach you the symbols of numbers. These are actually more. Okay, one last thing. We're gonna draw a little diagram. First off, natural numbers. What are natural numbers? Now, there are actually symbols for every type of number. So for natural numbers, you actually express it in this way, in this symbol, natural numbers. Okay? Now this is basically 1, 2, 3, 4, 5, 6, whatever. When you add in 0, you get the whole number, but let's not write that down. When you add in the negative side, from the entire scale from negative to 0 to positive, you get integer. To express integers, we put this. We put a z sort of. Now, if we want to express a positive integer, we just put z plus. Negative integer, z minus. Okay, but in this case, generally speaking, integers itself, just a z. Okay. Now, let's add in rational numbers. Rational numbers, you don't put a r, you put a q instead. So, the q will look something like this. The q looks something like this. I know it's kind of weird. Basically, just write a regular q, right? But then put a little stroke here. Boom. Now, if you take this and you add in irrational numbers. Irrational numbers, how to express it? you basically express it as Q apostrophe. It's sort of like an apostrophe thing over here. Like a little stroke over here, like an apostrophe. Okay? Then basically that means irrational number. Okay? Now, all this together, it will be under real numbers, which is expressed as this. So all real, all real, all real. Actually, I can't express it this way because it will look like. Okay, but never mind, you get my point. But there is still another type which is on itself, on its own, which is called imaginary numbers, expression like this, a C with a stroke there. Okay, so this is literally the brilliant world of numbers. And probably you came into this lesson watching, thinking, oh, how crazy could numbers be? But this is literally things that you don't realize, you don't know, but they actually do exist. So hope you learned something in today's video. It's actually very educative, very educational, not educative. Okay, please subscribe and like if you learned something. I mean, definitely did, right? Unless you already knew this before, but I mean, you definitely click on this video because you didn't know, right? So, thank you very much, okay, for your kind attention. Alright, I'll see you in the next video. Peace.